Linear versus exponential project.
Okay, the first problem. With the destruction of Earth, only 1,000 people have survived by moving to another planet. Over the years, the population began to grow again on their new home, planet Mirth. The population grows by 100 people per year. So first, we're going to set up our equation. Since there are 100 people growing per year, we would put 100x, x representing the years and 100 representing the amount of people per year. And it started with 1,000, so we would add 1,000 to that. With this equation, we can find our two problems down here. So, how many years will it be until the population reaches 2,000 people? First, we would look at our equation and see that 2,000 people would replace y for the total. So we would replace y with 2,000. We would subtract 1,000, divide by 100, and then we would get 10. So that would mean 10 equals x. Okay, for our next problem, it asks how many people will there be after 20 years. So what we do here is we would replace x with 20, because x represents the amount of years, and we would multiply 100 times 20, we get 1,000. I'm sorry, I meant 2,000. Then you would take the 2,000, add it to this 1,000, and you get 3,000. Therefore, in 20 years, the population will be at 3,000 people.
A long time ago, there was a scientist experimenting with chemicals to see if he could make the human population crazy and then die. To test his experiment, he tried it on cows first, which quickly spread to the other cows. This caused the price of milk to rise 25% each month. For our equation, we have y equals $3 times 1.25 raised to the x power. X is equal to the amount of months, and y is equal to the total cost of the milk. To get 1.25, we did 25 divided by 100, which gave us 0.25, and then 1 is 100%, so we did that to get 125%, which is equal to 1.25. And then by doing that, raised to the x power, so we can replace that with the amount of months, and let's say we do 2, that will give us what the price of milk will be in 2 months. Our first question is, how much will milk cost in 18 months? To do this, we use our equation, and then we replace x with 18, and we get $55.51. For our second question, it says, when will the price of milk be over $50? To do this, we typed it into our calculator, and we did y is equal to $3 times 1.25x, and then we went to second graph, and we went all the way down until we saw $50, and the price of milk will be $50 in between 12 and 13 months. There once was a forest that had a population of 500,000 squirrels. One day, the squirrels noticed that there was not enough nuts to eat. After that, the squirrels started dying by 250 each month. How many squirrels are left by the year 50? To do this, we do 500,000 minus 250x, and x stands for the amount of months. Our second problem is, when will the squirrel population reach 200,000? To do this, we type in the equation into our calculators, 500,000 minus 250x, and we go to second graph, and then we scroll all the way down to 1,200 months, and we see that the squirrel population will reach 200,000 in 1,200 months. For our equation, y is equal to the total number of squirrels, x is the amount in months, minus 250 is the amount of squirrels dying, and 500,000 is the starting number of squirrels.
Here's the fourth problem. 90% of carnivorous animals have been killed off by hunters. Because of this, herbivores increase by a great amount, but the plants are decreasing by half each month. There are 10,000 plants at first. So over here we have our equation set up, which is 10,000, which is the starting point, the start of the plants in the month. We have the amount it's decaying by right here, and then x is the amount of months. Here, down here, we have our two questions or problems. So the first one asks, how many plants will be left in 10 months? So first, we would come back to our equation, replace x with 10, then we'd multiply. First we'd take the half, raise it to the 10, and multiply these two together, and we'd get the total of, and we will receive about around 9.76 plants, which is impossible, but it doesn't matter. For our second problem, it says, how many months will it take for there to be less than 2 plants? So we go back to our equation. We're going to place y with less than 2. Then we do everything that we did before. So we'd find this by in our interval. Our answer would be actually between 12 to 13 months, around there.